Good afternoon, beta. Divya, Sharmila, Shruti, Rahul, Merunisa, Sharmila, Ashwin, Darshani, Ekta. Good afternoon, everyone. So today we are going to do a very important question. Chances of coming this question is very high. Expression for kinetic energy. This is a very, very important topic. Avinash, what error? Is there any error? Check that one out. Okay, good afternoon, everyone. Good afternoon, beta. Now it is okay? Fine. Now look here. So first just give a heading, expression for kinetic energy. Take out everyone notes. Your notes should be there because today we are going to do kinetic energy related numericals also, and you are going to write the expression for deriving kinetic energy. Last class, good afternoon Avinash. Last class we were doing, last class we discussed about work, energy, and then 1 joule is equal to 10 to the power 7 ergodine, whatever we can say. We have done that one. Aishwarya, good afternoon beta. Now today we are going to derive an expression for kinetic energy. So just give a heading everyone, expression for kinetic energy. Expression for kinetic energy. So how to derive kinetic energy? So we know that there are different type of energy possessed by a body. Now one is exactly by virtue of its position, one is by virtue of its motion. Then light energy, chemical energy, heat energy, different type of energy we have seen. Different type of energy we have seen. Okay. Yes, Keshav. Hello, Keshav. Good afternoon, beta. So different type of energy we have seen and we encountered and came to know about. So now what we are going to do, just 1 minute. So now we are going to derive it. So what is kinetic energy? So if somebody will be asking you about kinetic energy, what answer you are going to say about kinetic energy? So kinetic energy is what? Kinetic energy of a moving body is exactly by virtue of which the body will be having motion before coming to rest. Okay, before coming to rest the body will have motion. The body will have what? The body will have motion. So kinetic energy, not now. Hi Michael, your video I have made beta, just slight cut editing, and then I will be sending your video. Okay, after the classes I am going to release the video so that you can practice better. So kinetic energy, just write that the kinetic energy of a moving body the kinetic energy of a moving body is measured by, start writing, is measured by the amount of work, is measured by the amount of work it can do before coming to rest. Okay, before coming to rest. So if energy due to motion, okay, energy due to motion beta. So here if somebody will be asking you Sambar dosa, hi Sambar dosa, really missing your name yaar, it's really nice, huh? You know I like dosa so much. Dosa is my favorite. Idli and dosa, these are two meals na. How many times you will give, that many times I will eat. No complaints. Okay. Yeah, Berika. Nice name. No, I am not lying. Seriously, sambar is my favorite dish. Fine, shall we start? So now look here. So the kinetic energy of moving body is exactly measured by amount of work it can do before coming to rest. So how much work exactly before coming to rest, how much amount of work it can do. So we know that kinetic energy is the is exactly that type of energy which is exactly due to motion of a body, due to exactly motion of a body. So if you want to measure the energy of a body by its virtue of its motion, then we will be saying that it's kinetic energy, none other than kinetic energy. So we are going to derive a relation beta. So first work what we are going to do is find okay, fine. If all your activities are over, shall we start? Because auntie is really in a very nice stage of fine, fine. Keshav, Vishal, is it over? Shall I continue? Because really I am not feeling well. But okay, fine. Everything is possible. So now beta, just understand that. One simple thing I am telling, that a body is there of mass m. Now what you did is, you the body initial velocity is taken as u. Fine. So when you have given when see a body of mass m is there, now its initial velocity is u. So what you did is, you applied an external force. So once you applied an external force, now the body will have acceleration. Okay, that means the body will move. The body will have acceleration and the body will start moving. Now at the time it is moving, Naresh, good evening. Now examinations are very near, so please be very, very serious. Okay, let's study beta. Okay, Kanishka, thank you so much beta. You are so caring, huh? Yes beta, cold and fever is there, but everything all right. Now look here beta. So now after applying of external force, the body will come to m, another location. So now what you have done, you have exactly given force F. Once you have given force F to the body, now that means just take a ball and just slide it. So once you are sliding the ball will move from one place to another, means the body will have acceleration. Why the body will have acceleration? Because the body will have what you call application of external force is there. So you have applied an external force. Because of that external force, the body is exactly moving from point A to point B. The mass of the body remains the same. So the displacement of the body is S. Acceleration produced in the body will be what beta? Acceleration produced in the body will be A. Fine. Now initial velocity of the body is u. Now what will be the final velocity? The final velocity of the body will be v. So this is the informations what we were looking forward for. So the constant external, but here one thing will be there beta, we are not going to provide friction here. So we are going to say that okay, frictionless surface, we are going to take a perfectly frictionless surface. So once we will be taking perfectly frictionless surface in perfectly frictionless surface only, we have exactly taken the body and we allowed it to roll after application of external force. So till here I hope you might have understood. Come on, tell me beta, what and all I have discussed. I took a ball, the surface is frictionless. So what type of surface it is? The surface is frictionless surface. Okay, so that means frictionless surface, the surface is frictionless. Now what is the initial velocity? Initial velocity of the body, u is considered as the initial velocity of the body. Okay. Now what is v? V is the final velocity of the body. Final velocity of the body. Okay. External force applied is F. F is what? External force. External force applied. F is what? External force applied. So external force applied is F. Fine. External force applied is F. Now what is the mass of the body? The mass of the body is considered as m. M is what? Mass of the body. So Now what is happening here? So I'm just writing, you at the time of writing, I'm expecting my children to write that in the statement form. Fine. So when you will be writing, you must write this point that when a body of mass m is taken on a frictionless surface. So just I'm just telling what to write. So statement writing you are going to do. So that statement I am telling you, when a body of mass m is taken on a frictionless surface and an external force F is applied on it. Mark my word, what did I say? An external force F is applied on it, then the body will have acceleration, and the body will move from point A to point S, point A to point 2, having displacement S. So this is the statement what you are going to write. I didn't wrote the statement, I just wrote what in all points are exactly taken here. Fine. So I'm just repeating, when a body of mass m is taken where beta, it is taken on a frictionless surface and an external force is applied, then the body will generate acceleration. It will move from point A to point B and cover a displacement S. So So after this information beta, we are going to start our work. So now till here I hope everybody might have understood. What is S? S is the displacement. What is S? S is the displacement. Okay. So what is S beta? S is the displacement generated in the body from point A to point B. Till here everybody understood? Come on, quickly tell me beta. Till here everybody understood the point? What is S? Displacement generated. Understood? Yes beta, super. So now we will start our work. Now first we will take by using third equation of motion. So what we are doing now is we are using third equation of motion. So using third equation of motion, that is v square minus u square equal to 2as. V square minus u square equal to 2as. This is exactly what beta? This is the third equation of motion. So now what we are going to do here is v square minus u square by 2s equal to a, we can write. So now what we are going to do, we will take it as equation 1. Now, did the body did any work here? I just want to know that. Yes beta, here GS will not be applied Ekta. GS will be applied only when the body will have a vertical displacement. Here the body is having horizontal displacement. At the time the body is having horizontal displacement beta, that time we are going to take as v square minus u square equal to 2as. That time what we are taking? We are taking as v square minus u square equal to 2as. I hope you might have understood. V square minus u square equal to 2as. Okay, no problem Ekta, no problem beta. So now this will be considered as equation 1. Now, is there any work done here? Come on, quickly tell me. Is there any work done here? Yes, very good. So work done will be there beta, 100% work done will be there. But beta, first you have applied an external force. So what will be that external force? So now external force applied, that is according to Newton's second law of motion. So what is Newton's second law of motion? Can anybody tell me? What is Newton's second law of motion? What is Newton's second law of motion? So applying Newton's second law of motion, applying Newton's second law of motion. So Newton's second law of motion, what is Newton's second law of motion? Very good beta. Why we have applied Newton's second law of motion? Because this is a general question that will come na beta, ki why we have applied Newton's second law of motion. Can anybody tell me why we have applied Newton's second law of motion? Come on bacha party, tell me fast. Why we have applied Newton's second law of motion? Beta, because we have applied an external force. Okay, so since we have applied an external force on a body of mass m, and it is having acceleration, so we already know that Newton's second law is exactly telling that force is equal to mass into acceleration. So this is exactly Newton's second law. So by applying Newton's second law, we can say that force given on a body or external force applied on a body will allow the body to have acceleration according to its mass. Okay, so this is a very, very important point. Now I'm just asking a simple question that a body is there of mass 5 kg, another body is there mass 50 kg. Now which one I have applied same force of 20 Newton on both of them? Which one will have acceleration more? Which one will have acceleration more? Which one will have acceleration more? Which body will have acceleration more beta? Which body will have acceleration more? Come on, quickly tell me. Which body will have acceleration more? Very good. So why? Because its mass is less, so force is directly proportional to mass. Acceleration generation also will be. So that means a body of mass, less mass will have more acceleration. A body of less mass will have more acceleration. Absolutely correct beta. Super. So now what we are going to do is force is equal to mass into acceleration we are going to take. Super. So now this we are going to take as equation 2. Now beta, acceleration, one equation you have taken, v square minus u square equal to 2s. So shall we substitute here? So it will become, force will become v square minus u square by 2s into m. So substituting acceleration value, substituting acceleration value from equation 1 in equation 2. So we have just substituted acceleration value from equation 1 in equation 2 beta. Once we have substituted, now we have force. But beta, I told a very important point here that work is done. We should not forget that here work is done. Now what is the actual work done? Here work is done after application of external force. So whatever I had external, whatever energy I had, with that energy I have given an external force to the ball. Once I have given external force to the ball exactly moved from one point to another point. Very good beta. M will be inversely proportional to acceleration. Absolute. So increase in mass will reduce the acceleration. Correct only Keshav. Now here what is exactly there is once I have applied force on by using my energy, then the body will have displacement from one point to the another point. So since the body is displacing from point 1 to point 2, now that means there is a work done, because here force is also there and displacement is also there. Since force and displacement both are there, 100% there is a work done. So shall we write that is there any work done here? Is there any work done? M is inversely proportional to A. Absolutely correct beta. Is there any work done? So you will be saying that yes auntie, there is 100% work done. So work done by the body in moving from point A to point B. Work done by the body. Work done by the body on moving from point A to point B, on moving from point A to point B, point A, we are going to name it as A and B, better, huh? On moving from point A to point B, point A to point B will be equal to, work done will be equal to force into displacement, huh? Work done will be equal to what? Work done will be equal work done will be equal to force into displacement now beta. Now what we are going to do here is the displacement will be s. Now what is the force value? Force value is this one now. So we are going to substitute force value in equation 3. So now force value is what? Force value here is v square minus u square by 2s into m, and here displacement is s. So now this s and this s will get cancelled. So it will become half mv square minus mu square. It is considered as what? It is considered as half mv square minus mu square. Okay, this is exactly called as work energy theorem. This theorem what I have derived na beta, it is actually called as work energy theorem. So this derivation, that is work done, is equal to half mv square by minus half mu square will be exactly considered as work energy theorem. It is considered as what? Work energy theorem. Work energy theorem. So this theorem is exactly called as what? This theorem is exactly called as work energy theorem. So this theorem is called as work energy theorem. Fine. So now if initial velocity of the body is taken as 0. So if initial velocity of the body will be taken as 0, then what will be the work done? If initial velocity of the body is taken as 0 and initial velocity u will be considered as 0, then what will be the work done? So if u will be considered as 0 beta, then it will become half mv square minus half m u in place of u 0 square will be there. So finally work done will be half mv square. So it is only by virtue of its motion. It's only by virtue of its motion. Okay. It's only by virtue of its motion. So this work done is in fact what? So this work done is in fact is stored in the object in virtue of its what you call kinetic energy. This work done is stored in the body by virtue of its kinetic energy. So this energy produced, that means work done means the energy produced was transferred to the body, and the body will have displacement. Since the body is exactly having since the body is exactly having displacement from point A to point B, so what is exactly the body is doing? The body is displacing from one point to another point. Since it is displacing from one point to another point, it is displacing from one point to another point. So that time initial velocity once will be taken as 0, then the final velocity will be considered as v. So that will be exactly by virtue of the motion of the body, by virtue of the motion of the body. That's why the work done will be purely because of motion of the body. So now we know that when energy given to the body will be totally utilized to produce motion to the body, then that energy will be considered as kinetic energy beta, and that time the work done is exactly to bring kinetic energy in the body. Then this work done will get converted into kinetic energy. This work done will get converted into this work done is exactly converted into kinetic energy. Till here beta, tell me, I know I'm unable to teach nicely today, so I'm so sorry, but whatever I have explained, one more time check. This is a very very important point. So you understood or not? Come on, quickly tell me. Understood? By virtue of its kinetic energy. Understood, Ashwin? Very good beta, thank you so much. So we have understood one very important point is कि once we are, so yesterday also I have discussed this point that कि once we are giving once we are giving external force, means that external force application is usage of energy. So when I will have energy, I will give that energy to a body. The body will experience that energy as an external force, and then the body will have displacement. The displacement of the body the displacement of the body will be exactly considered, the displacement of the body is exactly considered as work done, because in physics we know that work done is nothing but force into displacement. In physics it is nothing but force into displacement. Till here my bacha party understood? So kinetic energy, so work done can be also taken as kinetic energy, because it is due to position, due to motion of the body. It is due to motion of the body. Okay, understood? Till here understood, beta? Till here understood? So what is the definition of kinetic energy? Can anybody tell me the definition of kinetic energy? Can anybody tell me the definition of kinetic energy? So kinetic energy of a moving body is defined as half the product of the mass and square of the velocity. Half the product of mass of the object and square of the speed of the object or velocity of the object. When a body is displaced in a motion, it is known as, yes beta, because the body will have displacement or motion. So since the body is having displacement or motion, the body will be considered to have kinetic energy. The body will be considered to have kinetic energy. Okay, due to its motion. Yes, energy possessed by a body due to its motion will be called as kinetic energy. I am repeating that point again and again. Energy possessed by a body due to its motion will be considered as kinetic energy. Due to its motion can be considered as kinetic energy. Okay, over. So what is the definition of kinetic energy? What is the definition of kinetic energy? Kinetic energy of a moving object. I am teaching correct only now. Half the product of the mass of the object and square of the speed of the object. And square the speed of the object. Yes, this is the definition of kinetic energy, beta. This is the definition of kinetic energy. I hope you might have understood. Till here understood, beta, what is exactly the definition of kinetic energy? We have derived kinetic energy now. So now what is the SI unit of kinetic energy? The SI unit of, because kinetic energy is a type of energy, the SI unit of kinetic energy is joule. What is the SI unit of kinetic energy? Is joule. Kinetic energy is directly proportional to mass and directly proportional to mass of the object and square of the velocity. Directly proportional to mass of the object and square of the velocity. If you have any doubt, I am seeing the chat box. Just tell me your doubts, beta. Tell me your doubts. If whatever doubts you are having, tell me your doubts fast. Whatever doubts you are having, tell me your commando. Understood, commando? What is that commando, Keshav? So what is the SI unit of kinetic energy? SI unit of kinetic energy is joule. SI unit of kinetic energy is joule, beta. Okay. So now beta, SI unit of kinetic energy is joule. Next important point is, thank you Kanishka. I'm having fever right now and I took medicine. I thought it will be okay, but standing is a big problem right now. My legs are shaking. Now look here. Kinetic energy of a moving body is defined as the product of mass of the object and square of the speed of the object. Okay. Now, now next is beta. Kinetic energy of a body is directly proportional to what? So kinetic energy of a body is directly proportional to kinetic energy of the body is directly proportional to mass, and kinetic energy of body will be directly proportional to square of the velocity. Okay, square of your velocity. Kinetic energy, mass and square of the velocity. Okay, mass and square of the velocity beta. So this is one thing, always remember that kinetic energy of a body will be dependent upon the mass of the body, means how much the body will have kinetic energy. It will be exactly due to the mass and the velocity generated by the body. So these two things are there beta. Next, SI unit of kinetic energy is joule. Next important point is that define okay, any exams are there beta? Your exams are having. How can I leave right now? I cannot. It's not possible. No, exams are there. I will manage. No problem. Okay. Okay, so this is exactly going to be the kinetic energy beta. So 1 joule will be equal to, so kinetic energy of a body is said to be 1 joule if the body of mass 1 kg moves with a velocity, moves with a speed of 1 meter per second. The kinetic energy will be what? So with the square of the speed or double the speed, moves with a speed of this 1 meter per second, moves with a speed of 1 meter per second. Here one very important point to be noted is that okay, when you will be writing 1 joule, so 1 joule will be equal to 1 kg meter square per second square. 1 kg meter square per second square. 1 kg meter square per second square. Fine. So it will be square of the speed will be 1 meter per second square, because beta velocity will be square will be there now, with the speed of this, square of the speed, with square of the speed shall we write with the speed of this, I just squared it, with the speed of this. So kinetic energy will be equal to 1 joule. Kinetic energy will be equal to 1 joule if 1 kg meter per second square. So if one body of mass 1 kg is having a speed of what you call 1 meter per second whole square, is having a speed of 1 meter per second whole square. I hope till here everybody might have understood. Okay, understood or not beta? Yes, it will be coming as joule beta. Till here everybody understood. Then we are going to go towards relation between kinetic energy and linear momentum. Relation between kinetic energy and linear momentum. What is that? Half mv square, correct only na? M should be 2 kg. No need. Mass you consider for 1 joule you have to take mass as 1 kg. For 1 joule you have to take mass as 1 kg beta. For 1 joule you have to take mass as 1 kg. Huh? Now shall we create a relationship between linear momentum and kinetic energy relation between relation between linear momentum and kinetic energy. Vishal, which part you have not understood? Which part you have not understood, Vishal? Tell me. Which part you have not understood? Tell me fast. See, kinetic energy is by virtue of the motion of a body. We understood that part. Now kinetic energy is said to be 1 joule. When kinetic energy will be said to be 1 joule, don't take half is a constant, don't take half. Here the unit will be exactly considered for from mass and velocity. So exactly mass of the body is considered as 1 kg. What is the SI unit of a body of mass? That will become 1 kg beta. So now when we will be talking about mass, the mass will be considered as 1 kg. Now speed SI unit is meter per second, but here the kinetic energy formula is half mv square. So kinetic energy formula is coming as half mv square. So that's what we are saying, that given a body of what you call kinetic energy of a body is said to be 1 joule, when it will be exactly having a mass of 1 kg and it will have a velocity of 1 meter per second whole square. When it will have a velocity of 1 meter per second whole square. When it will be having what? When it will be having a velocity of 1 meter per second whole square. And because of that only we have written. Okay. So here Vishal, we don't have to write half there. Half writing is exactly for the formula. For SI unit, half is a constant, and constant is not applicable for writing the what you call unit system. So for that only, beta, for that only relation between for that only it is taken as for that only it is taken as kg meter square per second square. Okay, for that only it is taken as kg meter square per second square. Vishal, understood na beta? So linear momentum, now we have to see relation between linear momentum and kinetic energy. Now you know that what is linear momentum. Linear momentum of a body is mass into velocity. Okay, momentum means motion generated in a body. Momentum means what beta? Momentum means, yes, Maronisa, I'm really, I don't know what I'm speaking right now. So I'm trying my level best to carry on because classes are very important right now. Now beta, look here, linear momentum. Michael, I have taken your class. I have made the video. Okay. Now look here. In between coughing and speaking, that part only addition have to be there. So relation between linear momentum and kinetic energy. So beta, linear momentum of a body is nothing but mass into velocity. Okay, so how much will be the mass? So here you have to exactly create a relation between linear momentum and kinetic energy. So we know that kinetic energy of a body is half mv square. Kinetic energy of a body so kinetic energy will be equal to half mv square beta. Now we know linear momentum. Linear momentum is denoted by this p and it is written as mass into velocity. So here mass into velocity is there. So what we are going to do here is 2 is there. So mass into velocity. So here mass will be there. So we are going to write m. Now what we are going to do here is we will be multiplying one more m there and we will be multiplying m down. So here half m square v square by m will be there. Okay, so I multiplied m up and down because we know that linear momentum is mass into velocity. So linear momentum is mass into velocity beta. So since linear momentum is mass into velocity, so we have written like that. So now mv whole square by m is there. So what is mv? Mv is linear momentum. So kinetic energy will be equal to kinetic energy will be equal to half linear momentum square of linear momentum by m, square of linear momentum by m. Okay, so this is one formula. Since we have to start numericals, for numericals this formula will be very important beta. For numericals this formula will be very, very important. Okay, so kinetic energy will be equal to half into p square by m, half into p square by m. Okay, so kinetic energy is equal to half into p square by m beta. So this formula we are going to use for solving numericals. Shall we at least solve one numerical? After that we'll start maths class. So the question is, a body of mass 2 kg is moving with a speed of 20 meter per second. Find its kinetic energy. Find its kinetic energy. Beta, this is very easy question. Try this question out. Very, very easy question. Try this question out. joules. Okay, let's check this one out beta. We know that kinetic energy will be equal to half mv square. So mass is given as 2 kg. V square will be coming. This and this will get cancelled. So 20 square will become 400 joule. So answer will be 400 joule. Yes, answer will be, Shrutika, answer will be 400 joule. Yes, answer will be 400 joule. Can I keep it till here beta? After this I have to start maths class. From today surface area and volume revision I have to start. Okay, so from now surface area and volume we will start. Tomorrow kinetic energy numericals we will do. After that we will do potential energy. So kinetic energy, potential energy, various forms of kinetic energy, transformation of energy, conservation of energy. Power, this is the last topic. Power, commercial unit of that will be the last topic. We will be using it. Okay, I'll start in 5 minutes, 5-10 minutes beta. Just I'll take some rest and then I'll start again.